Example 6 on page 186, we are told that the random variable x is distributed normally between or within a mean of 50 and a variance of standard deviation squared. Given that the probability of a certain variable x when it is less than 46 is equals to 0.2119, 0.2119, it follows that what we have now, we want to introduce the z, and our unfamiliar boundary is 46, giving us, if you want to introduce z, we have less than z less than 46 minus our mean 50 over the standard deviation. This probability is 0.2119. And of course, when we have the normal distribution model representing that information there, and z is less than, and the area is less than 5, so we are talking about our z being in that particular position. So it is negative. And of course, this is the region whose area is 0.2119. So this is very critical. So that because the tables do not give the value of z when they are negative, then we'll have to use the symmetry. And we know by symmetry, there is another value of z when it is positive, and this region is also 0.2119 by symmetry. So this is z. But please don't forget that our entire value of z will be negative. This one is just to assist us use the table. So if we're looking at that, the probability of the z less than z, we are looking at this boundary, plus the probability of z greater than z is equals to 1. And therefore, this is the probability of z greater than z. You can already see it there. So this one is this. So this part is the one that is being explained by that region, 0.211. So we are interested in getting the boundary z. So we can easily say that the probability of z less than small z is 1 minus what we can see here, 0.2119. And 1 minus 0.2119 is 0.7881. So the probability of z less than the boundary z, 0.7881. Having said that, now we need to go to the table on page 201 and identify the possession of this probability 0.7881, and we see what is the corresponding value of z, or rather what is the boundary. And page 201 gives us 0.7881. Yes, we are somewhere 0.8. This is 0.8. But remember, our value of z was to be negative due to the nature of our question. So our z is minus 0.8. Having said that, of course, we need to go back and find the value of the standard deviation. And we know very well our z is realized after substituting this to give us minus 0.88. So 46 minus 50 over the standard deviation is supposed to give us negative 0.8. Therefore, if you cross multiply using normal basic algebra, you'll find that our mean is negative 4 all over negative 0.8, which gives us a 5. So our mean for that very question is supposed to be a 5. Please take care. The arrangement and the procedures and all the steps, we should be able to find our mean to be 5. All right?